Hello everyone and welcome to this Neptune CFD simple tutorial. This video will show you how to create a simple study, set up the numerical model and post-process the results using ParaView. A PDF of this tutorial is available on the CodeSaturn website. First of all, you need to create a study. So in that case, we're going to use the create option, as you can see there. So Neptune CFD create -s the study name, -c the case name. It creates a simple directory and multiple subdirectories as case 1, mesh and post. We now need to copy the mesh we're going to use in the mesh directory. Once it's done, you need to launch the graphical user interface. You need to go to case 1 data and launch the following command, Neptune CFD. Once the graphical user interface is opened, you can expand every tabs, then go on mesh and add the mesh you just copied in the mesh directory. For the execution mode, you can let it at standard computation to be able to launch a CFD case. Then go on boundary zones and add 5 boundaries. There are going to be 1 inlet, 1 outlet, 1 wall, and 2 symmetries. The selection criteria corresponds to the color definition in the mesh. Then click on Calculation Features and select Eulerian multiphase for the Neptune CFD and choose User Defined. Then on Main Fields, there's going to be water and air. The air bubbles will be dispersed in the water. Then on turbulence models, we're going to set a K epsilon model for the water. And for the reverse coupling of the air, we're going to use large inclusions. Now on body forces, you need to add the following force in the Z component corresponding to the gravity. In closure modeling, for the dispersed momentum transfer model, change the turbulent dispersion as GTD model and the wall forces as none. Then click on interfacial area and for the air field, select a constant model with the default diameter of 2 mm. To be able to initialize the fluid, go on volume conditions and check initialization. Then click on all cells to define the field properties. So set the same parameters as in the video. As you can see, you can't change the thermal parameters because there is no energy resolution for this case. Then click on the initialization tab. Let the pressure as 1 atmosphere. For the water field, initially there's no velocity in the domain and the domain is filled with water. For the air, the same, there's no velocity in the domain and there's no air either. We now need to define the nature of the boundary conditions. So click on boundary conditions and set the inlet, outlet and symmetries condition for the different zones defined earlier. You can now define the boundary conditions parameters. So first click on inlet. For the water field, the fraction is 0.9 with a velocity of 1 meter per second. And for the air, a fraction of 0.1, so the sum equals 1, and velocity of 1. For the outlet, for the water field, the fraction is 1, and 0 for the air. Then nothing can be changed for the other boundary conditions. Now click on Time Settings. The time step option is going to be adaptive with a reference time step of 0.2 milliseconds and a time analysis of 3 seconds. In the numerical parameters, you can define the minimum pressure and maximum pressure. In this case, the velocity predictor algorithm is going to be mean velocity minus relative velocity, and unselect active reconstructions. In post-processing, you can define the log frequency, the output and the listing. In this case, we're going to have an output every 5 time steps. In the writer tab, you can define the output frequency for the post-processing. In this case, it's going to be n-stack format and an output every 0.05 seconds. Then on monitoring points, we are going to add 2 probes at the following coordinates. We are going to add several profiles. So the first one is entry. In .dat format. The output frequency is at the end of the calculation. The line definition is defined with the following parameters. So the S can vary from 0 to 1. You can add the scalars you want to post-process. In this case, the air velocity, water velocity, the air fraction volumic, and the pressure. You can do that for several profiles at different locations. Once it's done, you can run the calculation. For the post-processing part, we will use ParaView software. So you need to open your file, which is in the residue directory. The file name is resultsfluiddomain.case. You can add filters, for example, cell data to point data to have a better visual. Different scalars can be displayed, for example, the water velocity. You can also display the volumic fraction of air and the one of water. you.